everyone, welcome back to another video of CambiHub, and in today's video we'll be doing IGCSE Computer Science October-November 2022 paper code 12, the theory paper. And let's see what kind of a paper level this was, how you need to answer the questions, and let's see the core concepts covered in the paper and how you can tackle and some tips to ace in this subject. Starting with the first question, which says a bus station has a ticket machine. A customer can use the ticket machine to select and pay for their ticket. One input device is built into the ticket machine is the touchscreen. Obviously, using the touchscreen, the customer can select their menus and everything on the kiosk and pay for their ticket. Identify any other two input devices that could be built in the ticket machine. So we do have a touchscreen, but we can also put some kind of a webcam or a barcode, right, to identify the tickets, right? So we can either put a webcam, right? We can also put a barcode scanner, right, to scan their tickets or to scan the IDs of people so that everything is automatic. We can also put microphone and speaker is an output device. So but we can also put a microphone for people do for blind people to using that they can still book their tickets, right? The ticket machine has help icon that a user can touch to contact customer support. The ticket machine has an output device that allows the user to hear the customer support person. Now, obviously, we need to identify an output device. This is a very easy question. The most obvious answer for this is speaker. But yes, some people would like to write headphones also, right? Very rare answer, right? But still, headphones is also correct. We need to mention an output device. So it can either be a speaker or headphone. But in exam, do not write a slash and write both. Please only mention one because for this, your marks can get cut, right? So speaker and headphones. They have strictly said that you mention one of them only. Moving on to the C part, which says the touchscreen for the ticket machine uses resistive technology, right? Describe how resistive touchscreen technology operates to recognize a new user's touch. Now we know that the resistive screen is a technology which is made up of multiple layers, right? That's why it is called resistive because it is pretty resistive, right? So it is made up of multiple layers, and when you press the above layer presses the bottom layer or it touches the bottom layer, which completes the circuit. And due to this conductivity of electrons, when this circuit is completed, the this area where it has been touched is then calculated. So this is what you have to explain in theory, right? So let's see how you can make up an answer. So first of all, you need to mention the resistive screen is made up of two layers, right? Because it is a two-layer technology. It is made up of two layers, right? When the user pushes the screen, the first layer goes into contact with the second one, right? This is what we discussed. This is how the technology is used. This completes the circuit due to conductivity of electricity, of electrons, you can say, right? And due to this, right, due to this conductivity of electrons or electricity, right? And then this allows the computer system, right? This allows the computer system to calculate the coordinates of the location of the touch, right? This is how you can answer this question, right? Explain it and in a well structured way, right? Moving on to the next question, which says give two benefits of using resistive screen technology for the ticket machine. Now we know that the resistive screen technology is resistive, right? That's why it is called resistive. So it can resist things, right? See, the first benefit is it doesn't easily shatter, right? The screen will not easily shatter, right? Please keep this in mind. Even though resistive technology is strong, but it is very prone to scratches. However, if an impact comes onto the screen, it will not easily shatter because obviously there's a dual layer protection, you can say, right? The second best, advantage of the resistive screen is you can also use it with gloves. It can be used, right? You can simply write, it can be used with gloves. Why? Because see, it is two layers, right? It is two layers. So whenever I press at a position, it touches the second layer and the circuit is completed. So even if I have gloves, I can press the location and I can still use it, right? Whereas in the modern screens or in the capacitive screens, the screens that we have on our mobile devices, right? We cannot do that. We cannot use it with gloves because it does not have a two-layer technology. We're not pushing something, right? It is our fingers electricity that interferes with the electronic in electronic shield of the screen, right? So that's why this is an advantage. Now, two drawbacks of using touch screen, what do we call drawbacks of using a resistive screen? As I told you that obviously it is not very sensitive to touch because capacitive easily recognizes our fingers electricity on top, and as soon as it interferes, right, it is very easy to recognize a touch, whereas in resistive screen you might have to press harder, right? So lower response time, you can say, or not very sensitive to touch, right? The second point you can write as it is prone to scratches, as I told you, right? Identify one other touchscreen technology that could have been used. You can either mention capacitive or infrared. I'll mention capacitive, right? I hope this question is pretty clear to you. Moving on to the next question. The next question says, describe the stored program concept from chapter number 3. So what does the stored program concept say? The stored program concept is saying two things, right? Two main things. That all of my data or all of my instructions that is going on through the fetch, decode, execute cycle will be stored in the same memory, not in separate memory devices. It will be stored in the same memory and it can only be fetched at a single time, right? So these are the two things. The stored program concept states that all programs, all instructions are stored in the same memory and can be fetched one at a time. Can be fetched one at a time. The next question says the computer in the ticket machine as an operating system. One function of the operating system is to provide an interface for the user. State three other functions of the operating system. Now this is a very it's a question where you can write a lot of points, right? They've only asked three, but I wish I could have written multiple points, right? Multitasking, multi-programming, input output control, running software, memory management, processor management, file management, handling interrupts, providing security, right? A lot of things. So I'll write memory management, file management, memory management, file management, and interrupt handling. Right? Moving on. The computer uses a 12-bit binary registers to store data while it is being processed. Customers are given a denary ticket number. Give the 12-bit binary number that is stored in the register for each denary number. So we have to convert each denary number to binary. A pretty simple task, right? Let's start with 100, right? We have to prime factorize it by 2. So 2 5s are 10, answer will be 0. 2, when you divide 50 with 2, 2s are 4, 1, 10, 5, 25. Again, the remainder is 0. When you divide 2 again, right? So this time we'll divide it with 24, right? So 1, 2, but the remainder is going to be 1. Then 2, 6 are 12, remainder is going to be 0. 2 3s are 6, remainder is going to be 0 again. 2 1s are 2, remainder is going to be 1. So we'll start from the bottom towards the top. This is going to give us 1100 100 1100 100 1 2 3 4 5 6 7 8 9 10 11 12, right? 8 9, because obviously we have to give the answer as a 12 bit, hence we'll add 4 zeros behind it. So this becomes 5 zeros, sorry. 1 2 3 4 5 6 7 8 9 10 11 12, right? This is the 12-bit binary value. Let's see for 235 also. So for this, we'll divide it with 234. So 2 1s are 2, 0, 3 1s are 2, 1, 4 7s are 14. So 117, remainder is 1. 2, we'll divide it with 116, 5s are 10, 1, 6, 18s are. So 58, again remainder is going to be 1. We'll divide 2 with 58 now. 2s are 4, 1, 18, 9, 29, remainder is going to be 0. 2 1s are 2, 2 4s are 8, remainder is going to be 1. 2 7s are 14, remainder is going to be 0. 2 3s are 6, remainder is going to be 1. 2 1s are 2, remainder is again going to be 1. So the number is 111 because we start from the bottom to the top. So 11101011, right? 11101011. So 11110 11101, sorry, 11101 So 1 2 3 4 5 6 7 8 9 10 11 12. 4 zeros will be added. Let's convert 301 also, right? So we'll divide it with 300. So 2 1s are 2, 1, 10, 150. Remainder will be 1. 2. Let's divide 150 with 2. 7s are 14. 1, 10, 5, 75. Remainder is going to be 0. Let's divide 74 with 2. 3 is a 6, 1, 4, 7. 37, remainder is going to be 1. Right? Let's divide 36 with 2 1s are 2. 1, 6, 18. So 18, remainder is going to be 0. 2 9s are 18, remainder is again going to be 0. 2 4s are 8, remainder is going to be 1. 2 2s are 4, remainder is going to be 0. 2 1s are 2, remainder is again going to be 0. So 1 0 1, 1 0 0, 1 0 0, 1 0 1. 1 2 3 4 5 6 7 8 9, right? So 10 11 12. 3 zeros needs to be added at the start. So this becomes 0 0 0. Let me check from the marking scheme. 1 0 0, 1 0 1 1, 0 1, right? So our answer is correct. So this is how you convert a denary number to 12-bit binary number. Make sure that there are 12 bits. If the 12 bits thing is not satisfied, then you have to add zeros from the left, right? Show the denary ticket number that would be given to each customer for each 12-bit binary, right? So let's try doing this. So we put the base values on the top: 1 2 4 8 16, right? So and then it goes on, but then it's 0, so we'll cut down 0 values. Let's see, we have 1 here, 1 here, and 1 here. So 16 plus 4 plus 8, right? Which is going to give us 22, right? This is going to give us 22. Let's move on to the next value. So 1, 2, 4, 8, 16, 32, 64. So 64 plus 32 plus 16 plus 4 plus 2 plus 1. Right? This is going to give us 119. Similarly, 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. So 256 plus 512 plus 64 plus 16 plus 8 plus 1, which is going to give us 857. I hope this was pretty easy. Now let's see the hexadecimal version also. So we make groups of 4, right? And we write this is going to be 0, 8421, 8421. Right, so 4 plus 1, this is 5. 8 plus 1, this is 9. So this is 095 as the answer. Right, 095. Similarly for this one, we make groups of 4. Right, so we make groups of 4, we make groups of 4, and we again make groups of 4. 8421, 8421, 8421. Now we just add the 1 values. So 8 plus 2, this is 10. 9, 10, 11, 12, this is 13. And this is 1. So we know 10 is A, and 13 is D. So this is going to be AD1 as the answer. Let's move ahead. An automated water tap system uses a sensor and a microprocessor to operate. Water flows from the tap and the person's hands are placed underneath the tap, right? So water flows only when the sensor detects that there's a hand. Water stops flowing when the hand is removed. So we need to tell that how will the sensor and the microprocessor process, right, going to use it. So we just need to put a hand under the tap. What sensor can we use? We can use a motion sensor. So first point that we'll mention is a motion sensor will be used. Right? You could have also written infrared or proximity sensor. That would have also been correct. Right? The sensor senses this data, right? This analog data is then converted to digital using an ADC, which is analog to digital converter. Right? Now, this is where we are going to write that the microprocessor is going to compare this data into a preset value, right? It is going to compare it to a preset value, right? The microprocessor will compare this data with a preset value, right? If the data is inside the range, a signal will be sent, right? A signal will be sent to the actuator, sent to the actuator to turn the tap on, the flow of water on, right? Or turn on the flow of water. That's a better, uh, rephrased version of it, right? If the data is outside the range, a signal will be sent to the actuator to turn off the tap, right? And at the end, we'll write that this whole process repeats in a loop, right? So this is what essentially we're doing is we have a tap here, right? And we have a motion sensor here. So as soon as the person places their hand, the sensor detects this value. And let's say that the value is 10 centimeters. So if the value is less than 10 centimeters, which is it is within the range, the person and the distance between the tap is less than 10 centimeter, then that signal will be sent to the activator to turn the tap on. But if the person removes their hand, this distance will be greater than 10 centimeter, which is outside the range. Hence, the signal will be sent to turn the tap off, because this tells the system that the person has removed their hand and there is no need to continue the flow of the water, right? Three descriptions are shown of different systems. Identify the most suitable sensor that could be used in each system. This is a pretty easy question. You just need to mention the name of the sensor. It checks the air is dry in the garage that spray paints the cars. So since it is checking the air, it is going to check the moisture in it, right? It automatically switches on the headlights on the car when it is dark. So this is obviously it's checking the presence of light. So it's going to be a light sensor. It checks the soil in the greenhouse has the correct level of acidity. Pretty scientific thing. So a pH sensor, because we're checking the level of acidity, right? The pH level of the soil. Okay, let's see which one is true for RAM, SSD, and USB flash memory drive. This is a pretty tricky question, so please pay attention to it. It is a type of a primary storage. So primary storage is only RAM and ROM. Hence, the correct answer is RAM. SSD is not, and USB is not a type of primary storage. It is volatile. Only RAM is volatile, right? SSD and USB flash are non-volatile. It uses NAND and NOR technology, internal SSD, and USB flash memory device both. Remember, please note that this is not a normal USB. It is a USB flash drive, right? USB flash drives also use the NVMe technology, which is used in the SSD, right? They also run with the system of transistors and capacitors, right? Hence, USB flash drive is also the answer. It does not have any moving parts. Moving parts only exist in Blu-ray, red laser discs, or HDDs. So it's none of them. So nobody has Blu-ray. Nothing has Blu-ray, right? Out of these options. It is not directly accessed to the CPU. Anything, except the primary memory is not accessed by the CPU. Or the CPU doesn't have a direct access of it. Doris has data stored on her computer. She accidentally loses some data by deleting a file. State two methods she could use to prevent accidental loss, and how each of it would, prevent the loss. Right. So let's see. The first method could be that she could create. Really sorry for that. The first method could be she could create a backup. Right. Create a backup. Right. Create a backup so that the data can be restored, right? So that the data can be restored. Then she can set the access rights. How will setting the access rights help? So she doesn't delete files accidentally by herself, right? Because by putting access rights will ensure that she as a user does not have the rights to delete any data. So how will the examiner check your answer? Because you must be observing that there are, one, two, three, four lines, but I've only completed my answer in like one line. So see, Cambridge is all about utilizing your space and just writing to the point, right? To the thing where it is required, right? Not writing more than that. So how will the examiner check it? Create a backup. Okay, 1 mark for that. Reason being because this says that mention the mentioned the methods through which she can prevent a data loss. Then I've explained it also that the data can be restored. So 1 mark for this. So for this whole, I'll get 2 marks. Sets access right, again a method, so I'll get 1 mark for that. And she does not delete the file accidentally by herself, I'll get another 1 mark for that. So for this whole, I get 2 marks, and in total, I get 4 marks. Right? So this is how the marking is actually done. Moving on to the next question. Okay, 8 bits of data can be transmitted from one computer to another. Each byte of data has a parity bit. The data is also sent with the parity byte. Each bit in the parity byte allows a check to be performed on each column of the bits. A parity check is performed on the data, error is found on one bit. Table shows the data that was received. Right, the data is found that was received. Identify which bit has an error by giving the byte number and the bit number. So we also need to explain how the parity block process works. So let's see how do we do it. Let's find the errors in the bytes first of all. Let's find it in the bytes, right? So we are moving horizontal. 1, 2, 3, 4. So 4 ones here. 1, 2, 3, 4, 5, 6. 6 ones here. 1, 2, 3, 4, 5, 6. 6 ones here. 1, 2, 3, 4, 5. 5 ones here. A signal. 1, 2, 3, 4. 4 ones here. 1, 2, 3, 4, 5, 6. 6 ones here. 1, 2, 3, 4. 4 ones here. 1, 2, 3, 4, 5, 6. 6 ones here. 1, 2, 3, 4, 5, 6. So it looks like that the parity is even, right? The only odd one out is 5 because it is odd. So we know the error is in byte 4. Let's see bitwise. Now we're going vertical. 1, 2, 3, 4, 5, 6, 7, 8. Correct, it's even. 1, 2, 3, 4, 5, 6. Again correct, it's even. 1, 2, 3, 4. Again correct. 1, 2, 3, 4, 5, 6. Again correct. 1, 2, 3, 4, 5. Again correct. 1, 2, 3, 4, 5, 6. Again correct. 1, 2, 3, 4, 5, 6. Again correct. 1, 2, 3, 4, 5, 6. We have done some. Okay, 1, 2, 3, 4, 5. This only has 5, right? This only has 5. So the wrong bit that has been transmitted wrong is this particular bit. So the error is in this bit. This should be 1. Then the error would have fixed. So we just need to mention the bit number and the byte number. Right? So byte 4 and bit number is 5. How do we explain it? What did we do? We first counted. Right? We first counted all the ones. Right? We first counted all the ones. Okay? Then we figured out that an even parity is used. Right? Figured that out. Then odd number of ones was found. No short forms allowed. Once was found in byte 4 and bit 5. Moving on to the next question. Gian has a website that uses SSL protocol to make sure that the data is kept secure during the transmission. Give 2 ways the user could check the website's SSL protocol. So in most of the cases, the SSL protocol is checked automatically by your browser, but you can check the SSL protocol by checking if the protocol address or if the web address, right? If the web address is HTTPS, because essentially this S stands for the secure socket layer, right? Or your SSL. This S stands for that, right? And the second way is check if there is a locked padlock. Check if there is a locked padlock sign, right? State the name of the updated version of SSL protocol, TLS, which is Transport Layer Security. Transport Layer Security, which is TLS. Jian's system for his website has a proxy server. Explain why Jian uses a proxy server as a part of his website. Right? The first thing that you can explain is that the proxy server server acts as a firewall and filters the traffic to the web server. So it won't allow any connection that is in the blacklist or that is bad for the web server, right? It will act as a filter, right? Then to help this, what will this do, right? This will help preventing the DDoS attack. This helps prevent a DDoS attack, right? It helps prevent a DDoS attack, right? Allows faster response time, right, for requests. And lastly, the last point will be it stops malicious traffic to the server. Right, so these are all of the advantages of proxy server, which is also mentioned in your book. Okay, Jian sells products using his website. He wants to create a secure login system for his accounts. He is worried that the user login details may be gathered by a malware when they're logging into the account. So see, they're typing into the account. When they're logging, that typing is being key logged or that typing is being recorded. What type of an error is a keylog error? What type of a virus is a keylog virus? We call it a spyware, right? We call it a spyware. Give three methods that could be used to help prevent a user's login details being gathered by the malware, right? So how we can stop spyware from happening, right? So instead of putting a login method, we can put drop down boxes. We can simply put drop down boxes to prevent keylogging, right? Because when nobody has to type, how would keylogging be done, right? Second method could be installing an anti-malware, right? Installing an anti-malware to prevent malicious software from being installed into the systems, right, that are connected to the web server, right? And the next thing could be that you can install biometrics, right? Install biometrics more secure as it cannot be logged or recorded. So how would the examiner grade me here, right? Putting down drop down boxes, 1 mark. Installing anti-malware, 1 mark. Installing biometrics, 1 mark. Now their explanations: putting drop down boxes will prevent key logging, another 1 mark. Prevent malicious software from being installed, another 1 mark. And more secure as it cannot be logged or recorded, 1 mark. So for this I got 2, for this 2, and for this also 2. So 2 into 3, I'll get 6 marks here, right? Easy question, a pretty easy question. Just make sure that your concepts are you're well versed with the concepts. The paragraph describes how the web pages are obtained and not and displayed for the user. Complete the paragraph using the list of terms, right? So we need to, using all of these list of terms, we need to complete this paragraph and we cannot repeat any of the term, right? So the browser sends the dash to the DNS. A browser cannot send the browser itself to the DNS. A browser cannot sell the whole HTML language to the DNS. It cannot send the IP address to the DNS because that's DNS job. It cannot send the internet service provider to the DNS. It cannot send the MAC address because that's restricted to the system. It cannot send a presentation. It cannot send the protocols because they are using the protocols to do all of this. It cannot send a what is a structure? It's a random thing. Obviously, web pages and server would also not be sent. So the correct answer for this is a URL is sent. Right? A URL is sent. A domain name that looks up the corresponding IP address. Right? So URL and IP address are done. This is returned to the browser, which then sends a request to the dash. Then this sends the request to the web server to establish a connection, where the dash are stored, where the web pages are stored, because that's what is going to be rendered once the connection is established. Pages are stored. The website is written in dash, obviously, the website is written in HTML language, right? That is rendered by the browser. Simple, right? Moving on to the next question that says NAND, OR, and XOR are three types of logic gates. We need to tick all of these statements, right? Which is true. When both inputs are 1, the output is 1. So when both inputs are 1, the output needs to be 1. This cannot be true in NAND because it is opposite of AND. It is true for OR. It cannot be true for XOR, right? Because XOR is the like and like gate. So it will only be 1 when either one is off. So 1 0 0 1, it is going to be 1. So XOR it cannot be, and this is AND. NAND is the opposite of AND. So since this is true for AND, it cannot be NAND. If both inputs are different from each other, then the output is 1. So when the both inputs are different from each other, the output is 1. This is true for OR, this is true for XOR, and this is even true for NAND, because NAND is the opposite of AND, right? When both inputs are 0, the output is also 0. This is not true for NAND because it is the opposite of AND. So that's why it is not true for NAND, it is true for OR and XOR. If both inputs are the same as each other, the output is always 0. So if both of the inputs are same, the output is always 0. So right, so this is with XOR, right? NAND, or XOR, NOR, and NOT are all examples of gates. State the name of one other logic gate and complete this truth table. So AND or XOR is done for us, right? We can use a NOT gate, right? We can simply use a NOT gate. Oh, okay. They are saying that without except any of these gates, we have to use some other. So only AND gate is left. There is no other gate other than this, right? So we'll use the AND gate, right? The AND gate. So 0 0 is 0, 0 1 is also 0, 0 1 0 is also 0, but 1 1 is 1 in the AND gate. So that's all for today. Thank you everyone for watching this video. This is Pranay Arora signing off from CambiHub. You can visit our learning portal at www.cambihub.com. Obviously, you'll find all of the necessary details or the links in the description below. Because on this site, we have uploaded all the topical past papers, worksheets, and normal past papers, resources, and everything that you should, you can use for your study. Obviously, you can ask your doubts in the comments below, or you can email me at pranay@cambihup.com, right? The channel's name and .com, right? You can also visit our WhatsApp community. The link will be there in the description below, where you will get 24/7 free online support for all of your subjects, IGCSE subjects, right? We wish you all the best. Thank you, everyone.